Hi friends, welcome to all. In this video we are going to discuss about router packet forwarding decision. Before coming to this point, friends, if you are watching our channel first time or if you like to get these type of technical videos in future, consider subscribing. Also, don't forget to enable that bell icon near to the subscribe button so that you will get notification message whenever we upload a new video. Right, coming back to our topic, router packet forwarding decision. Okay, just consider a host wants to send a packet to another host. And here, if the destination host is in remote network, then this source host will send this packet to its default gateway. Then this router will decide this packet forwarding decision based on its routing table. Now this routing table may have these following informations such as directly connected routes or remote routes or may contain a default route. And all these depends on the configuration done by the network engineer. First of all, we will discuss about directly connected routes. Here we are going to use a CISCO router 2911 series. Just I will rename this router as R1. Now coming to this R1, you will go to CLI and we will see what are the interfaces available in this router R1. Here we will give no, enable. Here we are going to give the show command, show IP interface brief. Yes, so using this show IP interface brief command, we can see all the interfaces in this router R1. Also, we can see IP addresses if we configured. Also, we can see the status and protocol. In this router, we can see these interfaces: gigabit Ethernet 0/0, 0/1, and 0/2. Also, we can see this virtual interface VLAN 1. And here we can see the status and protocol. All these interfaces are administratively down. Also we can see protocol down. Now we are going to verify our routing table of this router R1 using this show command, show IP route. And here we cannot see any route specified in this router R1. Neither a directly connected routes, nor remote routes, nor a default route. Here in this router R1, we did not configure any interface or any protocol. That's why we can see this routing table is empty. Now we will see when this routing table is updated. What we will do here, we will bring this interface up, gigabit Ethernet 0/0. Okay, so we will go to that interface. Show, now we will go to configure terminal. We will go to the interface, gigabit Ethernet 0/0. Then here we will give a no shutdown command. And now here we can see this interface, gigabit Ethernet 0/0, changed state to up. Okay, we can see the status now. Show IP interface brief. Here we did not set any IP address for this interface gigabit Ethernet 0/0. Only we made this interface status up. And here we can see protocol is also down because this interface is not connected to any device. Okay, now we will see show IP route. Is there any entry? No, there is no entry. Now we will assign an IP address for this interface and we will try it. Configure terminal, we will go to the interface gigabit Ethernet 0/0. Then we will assign the IP address. Consider 192.168.1.1. Then this submit to mask. Okay, now we will verify it. We will press Ctrl Z. Now we are in privileged exec mode. Here we will give the show command, show IP interface brief. Now here we can see interface gigabit ethernet 0/0 IP address. It's ready. Status up, protocol is down. Now we will verify our routing table. Show IP route. Still our routing table is empty. Because this interface gigabit ethernet 0/0 we have to make active. This protocol also we have to bring it up. We have to connect this interface to some device. Okay, now we will minimize this R1 CLI prompt, and here we will take a switch, maybe 2960 series. Okay, we will rename this switch as S1. Now we are going to connect from R1 to this S1, a different device, so we'll use a copper straight through. We are going to connect from gigabit ethernet 0/0. Here we set IP address for this interface. S1 we will connect to gigabit ethernet 0/1. Now here we can see the link between this switch and router is up. Now we will come to this R1, and here itself we can see a message: line protocol on interface gigabit ethernet 0/0 changed state to up. Okay, that's great. We will verify show IP interface brief, and now we will see the protocol. Here we can see now it's up. Now we are going to give the command show IP route. Here is our routing table, and we can see an entry here. Here we can see C and L. C, it's connected, and here we can see that network address 192.168.1.0/24 is directly connected to this interface gigabit ethernet 0/0. Here we can see the network address, and here we can see the prefix what be given, and here we can see one more code L. This is link local, the IP address of that interface gigabit ethernet 0/0. Here we can see that address 192.168.1.1. So just to keep in mind these codes. C is for connected. Here we can see that, and this L is for local. Now we are going to shut down this interface gigabit ethernet 0/1 in this device switch. We will go to CLI, enable configure terminal. We will go to that interface. It's a gigabit ethernet 0/1, and we will give shutdown command. So here we can see gigabit ethernet 0/1 changed state to down, and here we can see the link between these devices S1 and R1 is down. Now coming to R1, here itself we can see the message line protocol on interface gigabit ethernet 0/0 changed state to down. Okay, so we will verify using the show command. Show IP interface brief. Here we can see the status of this interface gigabit ethernet 0/0, IP address there. We can see the status, it's up, but here we can see protocol is down. Now we will verify our routing table, and obviously there won't be any routing entry in our routing table. So we will see that using this command show IP route, and here we cannot see any route entry. Okay, now we will bring this interface up. We will give a no shutdown command. Okay, so we can see now the link between the switch and R1 is up. We can verify show IP route, and here we can see the route. We can see a connected network. So in this way, whenever the interfaces are active, we can see that many connected routes in our routing table. So here we will connect one more switch to this router R1. 2960 series. We will connect to gigabit Ethernet 0/1 to gigabit Ethernet 0/1 and we will rename this switch as S2. Now we will configure this interface gigabit Ethernet 0/1 in this router R1. Configure terminal, we will go to that interface gigabit Ethernet 0/1. We will set the IP address 192.168. We will give, okay, it's 168.2.1. then the mask. Then we will bring this interface up by this command no shutdown. Okay. Now here we can see the console message. Interface gigabit Ethernet 0/1 changed state to up. Also line protocol changed state to up. We can verify that using our show command show IP interface brief. Now two interfaces are up. Gigabit Ethernet 0/1 which is connected to our S2. Here we can see the IP address, status up, and we can see protocol also up. Now we are going to give the show command show IP route so that we can see the routing table of this router. Yes, now we can see two connected networks. Here we can see the second connected network. It's 192.168.2.0 is directly connected to gigabit Ethernet 0/1, and here we can see the IP address of that interface, that is link local. Okay, now consider we have two PCs in these switches. We will keep two PCs here. Now we will connect these two PCs from S1 FA0/1 to this PC, from S2 FA0/1 to this PC. Now we will assign IP address for these two devices. So here we have to use the IP address from the same subnet we used for this interface, gigabit Ethernet 0/0. We'll go to desktop IP configuration. We will give 192.168. It's a 1 dot network. We will give 1.10. Then the default gateway, it's here. Now we will configure PC2. Coming to desktop IP configuration, here we will give 192.168.2.10. we will give 2.1 is the default gateway. Now when this PC1 wants to send a message to this PC2, this PC1 send that packet to its default gateway as this PC2 in another subnet. Yes, once this packet reaches to the default gateway, I mean to this router R1, this R1 will take the decision, the forwarding decision based on the routing table. Okay, just we will see that using a simulation mode. We will go to simulation, and here we will give show all or none. Then edit filters. So here we will give only ICMP. Okay, right. So here we are going to send a packet from PC1 to PC2. So here we can see this ICMP packet will go to its default gateway because its destination is in another subnet. Now we will click on this capture or forward. Here we can see this ICMP packet goes to the switch S1. Then we can see it goes to its default gateway. And now once this packet receives in this router R1, he will take a forwarding decision based on the routing table. So we will check the routing table. Here we can see that packet is destined for our PC, that is PC2 with IP address 192.168.2.0. 2.10. So here we can see that network 192.168.2.0, and it says it's directly connected to gigabit Ethernet 0/0/1. Yes, hence this router forward this packet to that interface gigabit Ethernet 0/1, which is connected to this switch S2. We can analyze this packet. Coming to this outliers, so here we can see the details. Here we can see source IP address. Also we can see the destination IP address. Destination IP address is 192.168.2.10. So using this destination IP address, this router process. Right, now we will give capture or forward, and we can see it goes to this switch S2. Yes, because this router R1 taken the forwarding decision based on its routing table. Now we will give capture or forward again. It goes to PC2. Now PC2 sends acknowledgement back to PC1. So it goes back S2. It goes to router R1. Now again this router R1 takes forwarding decision based on its routing table, and we can see it goes back to S1 and finally to PC1. And here we can see this status, it's successful. Okay, now here I designed a small topology with 4 networks. Also I enabled EIGRP dynamic routing protocol. We will see that protocol, I mean EIGRP, in future videos, so stay tuned. Now in this topology, here we can see router R1, which is having 3 directly connected networks. Here we can see gigabit Ethernet 0/0, G0/1. Also we can see serial 0/0/0, which is connected to this router R2. We will verify this connected networks here. Show IP route. We can give connected so that we can see only connected networks in this router R1. Here we can see those 3 connected networks. Here we can see we have one more network which is unknown to this router R1. Right now it is unknown to this router R1 because already I told we configured EIGRP in this network. So when we send a message from this PC1 to this remote PC, that is PC3, R1 will take forwarding decision based on its routing table. If the route is available to this network, router will forward that packet to its destination. If not available, he will check for the default route. If this default route is not available, he will drop the packet. Okay, just we will go to this router R1 and we will verify the routing table. Show IP route so that we can see all the routes. Here we can see 3 connected routes and we can see 1 remote network. Here we can see the code D. D is for EIGRP. And here we can see that network address 192.168.4.0. So when we send a packet from this PC1 to PC3, we will see that using simulation mode. Okay. We'll send a message from PC1 to PC3. So we can see it goes to S1. It will send to PC1 will send to its default gateway because the destination host address is in a different network. Okay, here we can see now it goes to this router R1. Now this R1 process this packet. He will take the forwarding decision based on the routing table. Here we can see destination address is 192.168.4.0 network. Coming to router R1 routing table. Here we can see network address 4.0, and here we can see exit interface serial 0/0/0. Entry is available to this route, I mean to this network. So R1 will forward this packet to that exit interface serial 0/0/0. Here we can see that interface serial 0/0/0. So it goes to R2. Then here this R2 will take the forwarding decision. It goes to S3, and finally it goes to PC3. Okay, now we will see how this router take a forwarding decision using a default route. Here I reconfigured this topology. I removed all the dynamic routing protocol EIGRP from these two routers R1 and R2, and configured a default route on these routers R1 and R2. Okay, so we will go to this router R1, and here we will give this command show IP route, so that we can see the routing table of this router R1. Here we can see 3 connected routes, and here we can see a static default route, and also here we can see the exit interface is serial 0/0/0. Here in this routing table we can see there is no specific entry regarding this remote network 192.168.4.0. And here we configured only this static default route. Now we will try to send a packet from this PC1 to PC3 using simulation mode. We will go to simulation mode from PC1 to PC3. So here we can see our ICMP packet. It will go to its default gateway. Now it's in R1. Now this router R1 takes forwarding decision based on its routing table. So coming to our routing table, here we cannot see this destination network address, that is 192.168.4.0. So as we configure this static default route, this R1 will send this packet to this interface, to this exit interface serial 0/0/0. So we can see this packet goes to this router R2. So we'll give capture or forward. We can see it goes to this router R2, then it goes to S3, then finally it goes to this PC3. Okay, right. So friends, in this video we discussed about router packet forwarding decision. Also we have seen routing table. Now friends, if you have any doubt, any suggestions, please comment below. And if you like our video, give a thumb and share with all your friends. And don't forget to subscribe our channel for the future videos. Stay tuned, and we will meet again with the next video. Thank you.